Hi everyone, this is going to be the last example of chapter 6. It is question 121. Let's read the question. Question 121. Consider the circuit shown to your left. Write the three-loop equation for the loop shown. So you're shown a diagram like this. It has three loops. There's two power supplies, so V1 and V2. I forgot to write V2. All right, there we go. We got 5 resistance, so we got R1 over here, R2 over here, R3, R4, R5. We are also shown some current, I1, I2, I3, I4, I6, I5 and I6. Now note on the diagram, in the problem, the exercise section, I realized that this one is noted as I2. It does not make sense. This one is I2, so we have to use a different notation, and well, the natural one is I6 since we are already up to I5. All right, so we need to write the loop equation. I'm also going to write the junction equation. I think they are useful. The first thing we should do though is to write on which side are the resistance positive or negative. So let's have a look over here. The current is going in that direction for I2. So that means this one is more positive, this one is more negative. This one, I3, the current is going that direction, which means this one is positive, this one is negative. R4 is going to that direction, positive, negative. This one over here, it's I5, positive, negative. This one, R1, well, we don't see the current, it is over here, and the current is going in that direction, which means this one is plus, minus. All right. So let's start with the junction, the loop rule. We're going to start with L1. So note, there's 3 components in L1. There's V1 minus I2 multiplied by R2 minus I1 multiplied by R1, and this is equal to 0. Let's do the second loop. So the second loop, let's start over here actually. We are going in that direction, so minus I4 multiplied by R4. We are going in now in that direction. Note, we're going the reverse way for the resistance. We're going from minus to positive, which means this one becomes positive instead. So plus I2, R2. We are going into that direction, the third one. It is also positive in this case, so plus I3, R3. We are going the reverse way for V2, which means it is minus V2 is equal to 0. Now note again, same logic, there's a plus or minus. We are going from plus to minus. It's a voltage drop. Okay, let's do the third one. All right, so the third loop over here, we're going to go in that direction. Let's start at the same point we did previously. So we are going in the same direction as the voltage, so it is positive. We are going in the same direction as the current for R5, which means it is minus I5, R5, and that's it for the third loop. All right, so I'm going to be, so at this point we're done with the question. But I'm going to be solving, writing the equation for all the junction, all right? Obviously, there's no value in this question. It's only to write the equation, but I think knowing how to write all the junction equation might be useful. So pause the video if you need to. I'm gonna erase that section. Oh, and note, this one is also equal to 0. So I'm gonna erase these equations to write all the junction. And basically, I'm gonna denote there's 4 junction here. Oh, maybe not that one. All right. We got this junction. I'm gonna call it J1. This one will be J2. This one will be J3. And finally, this one is J4. But we're going to start with J1. So remember, the junction rule is all the current coming in equal the current coming out. We got 2 current coming in, I1 and I3. 1 current going out, it's I2. So that's it for J1. We're going to do J2. In this case, there's I4 coming in, I1 coming out, and I2 coming in. So I2 plus I4 is equal to I1. Let's do J3. So J3, we actually, this is an interesting situation. we got I3 coming out, I6 coming out, and I5 coming out, which means that we have 0 coming in, which is weird. It's not supposed to happen, which means one of our assumption here has to be wrong. But nonetheless, let's write, we nonetheless stick with our original assumption. We know right away that one of the assumption is wrong. So we got I3 plus I5 plus I6. All right. And finally, J4. So J4, we got I6 coming in and I5 coming in. So I5 plus I6 equal I4, which is coming out. All right. We got a 4 equation for the junction over here. Now note, we don't have any numerical value here. We add 3 equations for the loop, and we have 4 equations for the junction. So that's the reason why in the test you're going to have a two loop Kirchhoff law problem. Okay, 3 loop. If I were to put numerical value here, it will become very nasty. All right, so it will take a lot of time. You will see in the practice exercise though, there is one with a numerical value. You're free to give it a try, but like I said, it's not going to be on the test. But once you're able to solve a 3 loop problem, a 2 loop is going to be easy. But again, it is your choice. We're done with chapter 6. Next chapter, in chapter 7, we're going to talk about a special device called the capacitor. So see you in the next video.